Let's discuss a typical blending scenario where three radii converge in a corner and need to be blended. So in this case, we have a 100 millimeter tangent offset based G2 with a 0.5 form factor. Similar on this side, so 100 and 100, and 125 here. So my first thought would be when I see this scenario that since this radius is smaller than this radius and this radius is also smaller, I make the small radii blend around the large radii. That's a general best practice. You could have a sketch from a designer that shows the radius wanting to go this way, and that would be a reason not to use that general rule. But in this case, we're going to use that general rule. We also want to use a general rule that says we need 4 sides for a quality Class A surface. We can't make surfaces that are 3-sided. 3-sided surfaces can have normal issues at that edge of convergence where there is no 4th boundary. And I'd like to put that 4th side up here because I'm going to blend this radius around this corner. So we do that by simply creating a curve fillet, and I would like a curvature continuous, tangent offset, and I would like a 0.5 form factor, just like these other fillets have. And we'll create a blend between this fillet, not the surface edge, the fillet, because we're going to come back and make our blend continuous with the fillet, not the surface edge. Okay, and the same on this side, and just ask it to go. So it creates a 10 millimeter radius, and that looks a little small because I would like to see, imagine that there is a surface to this fillet, there's a perpendicular flange that comes off of here and intersects a point over here. I would like that tangent point to be about there. Okay, so I'm going to raise that fillet size. Oops, a nice thing with our latest curve fillet tool is that we can edit this. So let's go up to 30, and I'll give that a look. It still seems like 90 might be this way, so it seems a little small. I'm going to go to 40. There's no number here that's correct. Okay, I just would like these to be about 90 degrees. All right, and that looks good. The next thing I need to do is create a surface that goes from here right to that point. So to do that, I'm going to duplicate this edge and this edge. All right, pick those, set their pivots to the end and move them. Same with this. Oops. Same with this, pivot and move. All right, I'll turn off my shading so we can see what we're doing here. All right, and now I'll make just a basic skin surface between that fillet edge and there, and the same here. Okay, connect ends is good to have on in this case, because our next step will be to trim convert this surface to this nice continuous edge. Since it's based on the tangent line, it will automatically make this fillet's edge continuous up through here. All right, so to be sure we get that, I'm just going to, or to be sure we can get the trim convert to work, I'm just going to extend with merge on that skin edge and this upper skin edge. Let's just raise those a little bit, not too much. And then we need to take these 2 boundaries and their partners and be sure that those extend through this tangent and this tangent. So we'll just, oops, we missed one corner. So let's grab all 4 and just extend those a little bit. So now we get a nice clean intersection made there. All right, now I'm going to switch here so that my data gets organized, and I'll do a surface edit, trim convert, and I'm going to use intersect. So I'm going to trim convert this surface to the intersection of that slab we made and keep that portion. Same here, trim this surface, this slab here, that trim converts, okay? So now we have, if we turn our shading off, we have one, 2, 3 sides, right? And we simply need a fourth side on this boundary, okay? So to do that fourth side, let's use a blend curve, all right? So now we need, I'll delete my locators just really quick here. We can turn off all of our Alt-O to turn off all of our shapes. And I like to use a blend curve for this. It gives me some specific control that I'd like to show. So I'm going to create a new blend curve from that surface, so from my trim converted surface, out, and from this trim converted surface, and edit that and make it continuous with you. Edit this one, continuous with you. Now, what I need to do, and this is where, you can make things easier on yourself if you do this little technique here. So I need these CVs on this curve to line up with these holes on the surface that we're going to trim convert. It makes it easier on the computer. It has to do less mathematics when it makes that projection. So I'll move this over, okay, and maybe our curvature just a little bit. Now, here's the hull, and here's the CV, so we have a little gap. I might leave that little gap right there, all right, because I'm trying to match these to the CV locations of the trim converted edge. I don't know where that edge is yet, but I'm guessing. Here we have very little separation between our hull and our blend point, so I'll put this right on end curvature, all right? So now that we've done that, we can do a edit, trim convert, and I'm going to use projection, all right? So I'm going to trim convert this slab to this curve, and I'm going to keep this region, all right? You can see how those are pretty close to my blend points, okay? And now we should have our 4 sides. So I'm just going to grab this curve and put it over here. And now we have our 4 boundaries. 1, 2, 3, 4. And if you notice, they're all raw edges. So none of them are trimmed edges. This allows the square tool to work most efficiently. All right, so now we would go to square, and I'm going to create a transition. And the order doesn't really matter here, because we'll be setting boundaries for each one. Okay? So I'm going to adjust the continuity to be G0 for all of them. Okay? Boundary 1, I want curvature. Boundary 3, I want curvature. And boundary 4, I want curvature. All right? And that gives me not a bad surface, but not a Bezier surface. So rather than going and asking for explicit control right away, I'm going to look at some options in here called collinear. All right? And I want to make boundary 1 collinear, boundary 3 collinear, and boundary 4 collinear. All right? So without setting explicit control, when I tell the system to make those linear, what it's attempting to do is line all these CVs and all these CVs up in a linear fashion. Okay? So from here to there, it's theoretically a straight line. Okay? And it puts a pretty good blend in. What I don't like is the squishing or the expanding at the top. It looks like they get too wide. So I will use a couple of the sliders in here. So these 2 sliders can adjust the center of this surface. All right? So I'll slide this upper slider, maybe the bottom slider. No. And maybe I'll try this slider. Okay. Now that slider seems to be having the effect that I want. I want to have those CVs look nice and uniform. Okay. Now let's check our continuity. So we've got curvature continuity on all sides now. Bezier surface. Our last task is to be sure that this edge is continuous. So I'm just going to project that edge onto this slab, normal, and I'll project the square, not the fillet, because I'm working with the square now. Okay, I'm going to take that curve and stash him over here. I think I have another curve down here. Nope. And now let's check this continuity for curvature. And we get a little 0.01 gap problem. Well, there's two ways to fix this. One way is just to try to modify those two control vertices to achieve continuity. The issue with that is that this control vertice, which is controlling position for here, is also controlling curvature to here. So I would still give it a try. Do as much work as you can with the CVs that you have. So by picking a single CV and normal UV, I'll grab these two control vertices. Yes, I know I lose the history, and I'm just going to see if I can have a little bit of effect before I start losing my tangent continuity over there. So I'm moving this. Right away when I see this happen, I've gone too far. So I'll go up a little bit till that goes away. All right, that's as close as I can get this without adding a CV. If this max deviation was over here, I would begin moving this CV. But if you look here, when I start moving this CV, I might get it. It's possible. But if you look, see how now I'm losing continuity over here and over here. All right, so we'll leave that alone. Once we're this close, we'll grab this surface. I see it's the V direction. Okay, so I'm going to increase this in V, move one CV right here, and just bump him a little bit. All right, now we may have to go up with this, just a touch. This could just take a second to get in here because we're working to some tiny, tiny tolerances, okay? Now that we've got that done, let's trim that top, all right? And delete our locators and just have a look at this surface. Okay, so we've just created kind of a perfectly curvature continuous surface. Nice highlights. All right, ISO angle shows good. Isophotes track well. Okay, black and white stripes look good. All right, so that's creating a Bezier blend between different radii with the fourth edge. That technique you should learn and master because it'll be your bread and butter.